What's up, guys? In this video, we're going to be diving into the thin wrapper API functions for processing pickled data within Python from the maci library. Now, to give credit where credit is due, the thin API functions used for the maci library that enable some of this pickle functionality utilize and wrap the native pickle library shipped with the Python standard library for its underlying functionality. Now, the underlying mechanics primarily deals with pickled byte objects within Python, which I'll example shortly. But before we dive into that, I want to make note of the security awareness when handling pickled byte data or pickled data in general within Python. It is important to evaluate handling your pickled data very carefully, as it can be very insecure in dealing with pickled data. I highly recommend referring to the official Python documentation site for more information on pickling your data and some of the security concerns associated with it. Now, the maci language itself somewhat can kind of compare to pickling your data, but it's not the same at all. One of the reasons why you'd want to pickle your data is to store the state of an object or some data and load it back into your Python program. But one of the main security concerns of loading your pickled data from a file, it could contain executable code that could be dangerous when loading your program. Even Python's documentation also states that pickle is insecure for that reason as well. But there are recommended methods out there to make sure that pickle can be secure for that purpose. With that said, the maci language itself, not pickle functions, maintains a different, more secure approach with techniques to ensure that loading Python data is not susceptible to code execution like what you would expect when you load a .py or .pickle file. And even though that's their native design, which is totally fine, loading your configuration data, even from a .py file, is not necessarily the best way to do it, as again, even loading a .py file can run executable code. So if you're just trying to store generic data with like variable names or attribute names and values, then it's significantly better and much safer to utilize either maci to store your data, or it is more widely accepted to use common serialization formats designed for storing values if you want. Now, whether you use maci for that purpose or not is up to you, but there are many options out there. For example, JSON or YAML. Now, hopefully it's been made evidently clear that dealing with pickled data can be dangerous, and it's better to use other formats just for storing data values. But if you understand that already and have a more specific use case for using pickle, then I do have a basic technique that I'm going to demonstrate to you that can be a little bit safer than storing your pickled data directly to a file or creating a pickle file itself. Maci itself is not assuring protection at all and is not liable for any security concerns that may occur within your program, as any support or extra help to provide an extra safer technique is just extra help, but is not guaranteed to be completely protected, as nothing is 100% secure in the world, but we do the best we can to make it a little safer. So I'm going to go ahead and create a simple class with some basic data and pickle it, but using the thin API functions to make this work. So I've gone ahead and created a simple object using some of the test data that we've been using throughout the series for our example game save data. I've gone ahead and instantiated this class and created a simple object. What I'd like to do is store the state of this object into a pickled byte object. So within maci, it only offers two options, which is storing your data as a byte object. So if I do maci.pickle, you'll see that there's only the ability to dump your data to bytes or load your data from bytes. So let's go ahead and check out the dump bytes. And if we hover over it, you see all it does is accept any kind of data type, and then we can dump our data to a pickled byte string. Now, if you're not used to doing this and instead storing it to a file, this can be an added step to implementing better security, because you can actually check the state of your byte data before deserializing it. Now, you don't have to use maci to do this. The underlying functionality is pickle itself, so you can do this from the standard library if you'd like. Again, this just offers a simple API to access this functionality and make it straightforward for you. So a little bit safer idea would be instead to store this data as a byte string into the file assigned to a name. When the file is loaded back into the program, we can actually check that specific byte string's integrity and go from there. Now, not to say this is providing more security, but because you are assigning your byte string data to a specific name value, that can also add a level of obscurity of knowing where the pickled data is located. So what I'm going to do is go ahead and create an empty maci object and store the value of our pickled object into an attribute name and have it dumped to a file. All right, so all I did next was create a simple empty maci object using the build function. And then on my maci object, I created an attribute name called pickled data. And then I'm assigning it to the output of my pickled dump bytes, which should return a byte string like it says. So let me go ahead and pass in my object. And now I'm going to go ahead and create a new file. So I'm going to use the dump function, pass in the file name variable that I created at the top there, and then I'll pass in my maci data. So now when I run this, we should get a new file with an attribute name that contains our pickled data. So I'm going to run this. Now you see a new file was created. And if I drag this over, we can see that there's a byte string of our pickled data, which contains everything inside of our custom object. So now let's just pretend we want to change the state of this object and restore it to the file. So let's say at some point in the program, I change the state of my object and add a new attribute. We'll just say new adder, and we'll just assign it the string value of new data. That's fine. And then, on our maci object here, we have it, and then we assign the serialized pickled data into that attribute name in our maci data. And we'll even create a new maci attribute just to kind of show some variance here. New data, and assign it just data. And we'll create one before it as well. We'll make this one some data. Just like that. And so we'll go ahead and store this to the file again. And because we're using dump, it's going to overwrite it. So let's go ahead and run this. And so here's the state of our maci file. We have our attribute names and data or whatever. But we also have our pickled data, which is our attribute name, which stored the state of our pickled data. Now you might be wondering, why are we doing it this way? You don't have to store your data this way. In fact, this returns a byte string and you can store it however you please. But I'm just offering an alternative solution to storing your pickled data to a file instead of using a straight pickle file, which those are executable by nature. And this enables more control over checking the integrity using your own means of the data being processed. Because now when we go ahead and load the file back into our program, we're not loading a pickled file, we're actually loading a configuration file with our stored byte string data. So now let's go ahead and see how we can load or deserialize that byte string and restore our pickled object. Okay, so I've gone ahead and removed all the code just to example that the state of your object is truly stored in that byte string. So first we'll go ahead and load our data from the file. We'll use maci.load. We'll pick our file name and we'll assign this to a variable called maci data, which should give us our maci data object. And now, if we want to get our original object back, we just need to deserialize that byte string. However, I want to make note that running this code at this state has already loaded your byte string data of your object. So you can actually do some security checks and check the integrity of it before you actually deserialize it, which can add an extra layer of safety. So for example, if I go ahead and run the print function here and type in maci data, and then type in pickled data, and run the code, you'll see there's our byte string data stored in its original state. But we actually haven't deserialized this yet, so it actually hasn't executed. So again, that's adding an extra layer of safety on some checks you can do before you deserialize it. So let's go ahead and pretend like we've done some checks. And then finally, I'll go ahead and deserialize it and get our object back. So all we need to do is to run the maci.pickle load bytes, which just accepts our byte string, and then we'll access the maci_data.pickled data attribute. And this should deserialize our pickled data and give us our original object back. So if I bring our print function here, I should be able to access my object and then type in username, and we'll add another one here and type in money. And I should get both of those values back from our original object. And actually, let me grab the new adder attribute that it originally had, so we can see that the state change was truly stored. My apologies, I almost forgot that the class in this example needs to be defined, otherwise the object won't know how to instantiate it from the class name. So I've gone ahead and just quickly added the class name, and now when I run this, we should see the state of our object and its last values that it had, loaded from the file. But that's it. That's how you utilize the pickled API functions within the maci library in order to serialize your data to a byte string and deserialize your data from a byte string. Again, please evaluate any security concerns from any untrusted input or untrusted serialized data when you're unpickling your byte objects. And with that said, that's going to go ahead and wrap up this video. Hopefully this information was useful to you and will help simplify some of your projects. Thank you so much for watching, and take care.